Hello everyone. Today we are going to work on solving quadratic equations with one last method, and that is to solve using square roots. So just a couple reminders about squaring and square roots. When you square a number, that means you're multiplying by itself. So when we look at the number and we say square 5, 5 squared is 5 times 5, which is equal to 25. A number that is multiplied by itself to form a product is the square root of that product. So if we look at the square root of 9, that's 3. If we look at the square root of 25, what we're asking is what times itself equals 25? Well, that's 5. But it turns out that it's not just 5, it's actually also negative 5, because 5 times 5 is 25, but negative 5 times negative 5 is also 25. So that radical symbol is used to represent the square root, which when we have the square root, we're asking what times itself equals that number under the radical. And so we have positive real numbers have two square roots. So when we say a positive square root of the square root of 9, that's 3. And the negative square root is the opposite of that, which is negative 3. So let's just review a couple of these problems. If we were in class, we'd probably have you just do all of these, but let's just take a look at a few. 3 squared, that means 3 times 3, that's 9. Negative 3 squared, that means negative 3 times negative 3, which is still positive 9. Now, this is different. This is saying take 3 squared, which is 9, and then take the opposite of it. So now that becomes negative 9. So the square root of 9 is really, the square root of 9 is 3. And normally we would say, well, 3 times 3 is 9, and negative 3 times negative 3 is 9. But when we have the square root symbol, we are only asking for the positive square root. Okay? If we want both roots, then we put a plus or minus in front of it. And this kind of goes back to that quadratic formula we were doing as well, and that's why there was that plus or minus in there, so you could allow for both values. So just remember, keep those things in mind. And also remember, if you look way over here to number 10, the square root of a negative 100, that's no solution. Remember, we can't take the square root of a negative number, because if we try to take the square root of negative 25, we ask ourselves what times itself equals negative 25, and the only thing that's possible is 5 times negative 5, but those aren't the same values, so that's not going to work. So that's why that's no solution. So moving on, the learning target today is I can use the square root property to solve a quadratic equation. And we have a day 1 worksheet that you're going to work on. And this is our last method of solving. And so after we do this for a couple days, we're going to review and get ready to test on all the methods of solving a quadratic to find those x-intercepts or zeros. And speaking of that, okay, this is what we're doing right here. We are finding the zeros. And so when we solve for x here, x squared equals 4, we're asking, what we can do is we can undo it by taking the square root. But if we go back to what we did with quadratics, we could set this equal to 0 and we could factor it, because two numbers that multiply to negative 4 that add up to our 0 term in the middle would be plus or minus 2. And since that equals 0, then we get our x equals negative 2 and x equals positive 2. So we could still solve these with our other methods, but when we only have an x squared and not an x to the first, okay, and it's not as complicated, then we can just solve by taking the square root of each side. So remember, the reason that we have these two different answers is because we have two roots. So remember, you always need to make sure you're including that negative solution and there's almost always going to be two solutions. There is possible no solution, and there is possibility of just one because it's the same value. So here's some more information. Again, anytime during this video, if you want to pause it to take down the notes, great. Also, of course, there's a blank lesson for you to follow along with. So it says to solve, this is the square root property. To solve quadratic equations in the form of x squared equals a, we're going to take the square root of both sides or undo the exponent on x. Because squares and square roots are opposites of each other, they undo each other. They undo each other because if I take a 4 and then I square it, that gives me 16. And then if I take 16 and take the square root of it, it brings me back to 4. So it's just like multiplication, division. They kind of are opposites of each other. So our goal here is to always get what's squared by itself. So that's a really key thing to keep in mind, that you have to get what is squared by itself. Once you have what's squared by itself, then you can take the square root. So just looking through these notes, if we have x squared equals a, then we take the square root of each and we get x is equal to plus or minus a, or this is kind of what we did with the quadratic formula. And here's an example of this over here. Now if we take a look at this example, x squared equals 15. Well, x squared is by itself, so we take the square root of each side and we get x is equal to plus or minus the square root of 15, which we could leave like that, or we could actually have the decimal equivalent. And if we are going to round, we always round to two places, so we would get 3.87. So also we could have x equals plus or minus 3.87. So either of those answers are acceptable, okay? So let's just work on solving a few of these. I'll go through some examples. I'll try to highlight some common mistakes, and then we'll get you started on the homework. So we have x squared by itself. So all we're going to do now is we are going to take the square root of each side, and then what we get is we get x equals the square root of 169. You do that on your calculator, but that is 13. So you get plus or minus 13. Okay, so let's go on to some of the more difficult ones. I mean, let's look at C. It looks pretty simple. I have what's squared by itself, but when I take the square root of each side, I can't take the square root of this negative 25. That negative is a problem, so that one is no solution. So again, this matches right in line with quadratic formula work we did. So here we don't have what's squared by itself, okay? X squared is not by itself. There's an additional plus 7 there. So we have to get what's squared by itself, so we subtract 7 from each side. Then we get x squared is equal to 0. Now you might think that's a problem. Oh no, what do? Well, we just end up taking the square root now of each side. And when we take the square root of 0, we just get 0. And you might be going, oh yeah, every time you physically draw the square root symbol on your paper to undo that square, you need to make sure you include the plus or minus. But 0 doesn't really have a plus or minus, and that's when we get just no one specific solution. Okay, now over here, we add 32 to each side to get what's squared by itself. And then we get x squared is equal to 49. So now we have what's squared by itself. It's all by itself. Okay, we have to get what's squared by itself. And then we get to take the square root of each side, take the square root, take the square root. I drew that on my paper, so it's not just 7. It's plus or minus 7. And you're going to see it's not always going to be the exact same, like 7 and negative 7. We're going to get some different answers, just like we did with quadratics as well. We get a little bit more complicated as we go on here, because now to get what's squared by itself, I not only have to add 8, but I'm going to have to divide by 3. So first I add 8 to each side, which gives me 27. But I still have 3x squared equals 27. I don't have this by itself yet. So I have to still get this by itself, and it's not by itself. I got to get it by itself before I can take the square root. So I'm still going to have to divide by 3. Now I get x squared equals 9. Now I have what is squared all by itself. So now I can take the square root of each side, and so I get x equals 3, but also negative 3 times negative 3 is also 9. And there's a few more complicated ones. I'll do just a couple more, but I'll post all of the worked out solutions so that you can see any of the additional problems that we didn't encounter. So again, goal, whoops, let's undo that. Let's go back here, and all right, so we're looking at getting what's squared by itself. We're getting at what's squared by itself right here, okay? Don't be freaked out every time you see a negative. You've got to work out the problem to see if it's going to actually be no solution. So if we keep moving forward here, to get what's squared by itself, the first thing I have to do is subtract 3. This goes back to our equation solving, sort of the opposite of PEMDAS. So now I get 5x squared equals 125. Now I don't have what's squared by itself yet, so I can't take the square root. I've got to divide by 5 first, and that gives me x squared equals 25, and then x equals plus or minus 5. Okay, let's go to this second one over here, the very right side one, and I don't have what's squared by itself, so I'm going to divide by negative 8. Looks simple enough, but what happens when I do that is I get x squared equals negative 4. So I have this squared piece by itself, and when I try to take the square root of negative 4, that's a problem. That negative right there. I can't take the square root of a negative number, so this is no solution. Now you're going to find in Algebra 2 you can actually take the square root of a negative number in the imaginary number system, but we're not working in that right now. All right, so here's our last couple problems. These get a little bit more complicated. The first one, it's only complicated really because you have the x on the other side, but otherwise we're doing the same steps that we've been doing. Okay, we got to get what's squared by itself. It's kind of wrapped up with multiplied by negative 9, so we're going to have to first subtract 192. When we subtract 192, again, use your calculator. Don't make simple, it's fine to, to give it a shot in your head, do the mental math, but then check it so you don't make mistakes, especially on a quiz or test. So now when we take 48 and we subtract 192, we get negative 144. And that is equal to negative 9x squared. So now I have to divide by negative 9. And when I divide a negative by a negative, I get a positive. So I get 16 equals x squared. So now I take the square root of each side, and I get x equals plus or minus 4. Or you could write it with the plus or minus 4 on the opposite sides. So plus or minus 4 is equal to x. It's the same. Now the next one, what's different about this is notice that you have x squareds on each side. So you still have to get it alone, but you have to get them on the same side. So you solve all of these to get x squared by itself. You solve all of them the same way you would a regular equation. So to get my x squareds by itself and combine them on one side, I have to move them all to the same side. So that adds up to 0, and then this gives me 7x squared minus 35 equals 28. So again, now I have the x squareds on one side, but I need to get them by themselves. So now I'm going to add 35 to each side. Now I get 7x squared is equal to 63. Again, this is not by itself yet. So first I have to divide by 7, and then I get x squared by itself now is equal to 9. And you probably already figured out that when you take the square root of 9, you get 3. But don't forget, you also get negative 3 times negative 3 is also a solution. And last but not least, This one is just complicated because the equation is trickier. And a lot of people, what students want to do is they want to subtract the 32, okay? But we can't do that yet, okay? This is 3x squared plus 32 all divided by 10. The last thing I did was divide by 10, so that's the first thing I need to undo. So to undo dividing by 10, I'm going to multiply each side by 10. And now that gives me 3x squared plus 32 equals 140. So now it looks more like the ones we've solved. So we'll go ahead and we will subtract 32 on each side. That gives me 3x squared equals 108. Now I divide by 3 and I get x squared equals 36. Okay, I've got my x squared finally by itself. So now I can take the square root of each side, and x is equal to plus or minus 6. So do your best to just walk through these examples, look at them again, and then go back to Schoology and open up the assignments in Chapter 9 and look for the Day 1 Square Root Property Worksheet. I'll also post an answer key. Please check your work. Please show some work, maybe not on some super simple ones, but show me some of your steps so I can see your thinking. Have a great day, and let me know if you have questions.